Assalamualaikum and good night, everyone. How are you today? Are you able to hear my voice or not? Fine, okay, good. Alright, so tonight we discuss Kelantan paper 2. Okay, so I hope that we can discuss from question number 1 until question number 8. So we focus on the structure question only tonight. Alright, so can we start now? Alright, so as usual for your paper 2, list of formula will be given. Okay, and then this is the standard formula that will be given. So make sure you know the symbol. Alright, so I don't want to look at this. Okay, we straight away look at question number 1. Okay, question number 1, 60 marks. Oh, bukan. Section A. Section A is 60 marks. So these are compulsory question that you need to answer. Okay, look at question number 1. So this question come from what chapter? You can write your answer in the chat box, okay, so that I know the response. Alright. Yeah, so this is electronic, form 5, chapter 4. Okay. Now, okay, look at the question. Okay, you can read the question first. Okay, so when you answer the question, make it a habit to underline the keyword. Okay, so that the second time you read, what you underline will be more obvious. Okay, so diagram 1 shows a cross-section of Maltese cross tube. Maltese cross tube used to study the characteristic of the cathode ray. Okay, cathode ray. Okay, so here, okay, the filament is connected to low power supply. Okay, so the filament is normally connected to about 4 to 6 volt power supply. And then this filament will be heated by the battery lah. Okay, low power supply. Low power supply. So when the filament is heated by the low power supply, electron will be emitted from the surface of the hot metal, means at the surface of the filament. So what is the name of that phenomena? Okay, what is the name of the phenomena where the electron will be emitted from the surface of hot metal? Start with T. Okay, good. Yes, thermionic emission. Yes, thermionic emission. So the electron will be gathered outside here. Okay. And when you switch on the extra high tension power supply, so this one will be more than 1 kilovolt. So normally we use around 3 kilovolt. Okay, so when the extra high tension power supply is switched on, so the electron will accelerate, okay, towards the screen. Okay, because it gain more energy, so it will accelerate towards the screen. And when it collide with the screen, so you will see green light. Okay, green light. Now, look at the question. So, what is the meaning of cathode ray? You can type your answer. I give you some time for you to write your answer. So, what is the meaning of cathode ray? So, this is a famous SPM question. Okay, beam of fast-moving electron. Any other answer? High-speed electron ray. Any more answer? Electron move at high velocity in a straight line. Beam of fast-moving electron. high speed electron, alur elektron bergerak dengan hal laju tinggi. Ada lagi? Any more answer? Okay, so the keyword will be fast moving electron. Okay, if you write your answer as fast moving electron, that is already correct. Okay, cikgu tak perlu tulis. I don't have to write here. Okay, so the cathode ray is fast moving electron. Okay, so we look at that keyword. High speed electron, fast moving electron. Okay, they have same meaning. So it will be given 1 mark. Okay, so we move on to the second B. B. So diagram 1.2 shows a shadow and a green light region seen on the screen when switch S1 and S2 are switched on. So when S1 is switched on, you only will see yellow light. Okay, that is the normal light. Okay, that move in a straight line. So that's why you see the shadow. And if you switch on the S2, you will see the shadow will still at the same place and you can see green light. Okay, now look at the question. So this one is when S1 and S2 are switched on. Now look at the question. So the shadow is formed. Give a reason why shadow is formed on the screen. Why shadow is formed on the screen? What is the answer? Show again. So when S1 and S2 are switched on, shadow form on screen. So the question now, give reason why shadow is formed on screen. Okay, Zheng Yang answer cross block. The cross block the light ray. Cathode ray is blocked by the Maltese cross, forming shadow on the screen. Light ray travel in a straight line. Light travel in a straight line. Ada lagi? Electron block and transfer away by Maltese cross. Light move in a straight line. Electron is blocked by Maltese cross due to light from the filament. Okay, see. Alright, now. So this is actually what you learn in primary school. Okay, so shadow is formed due to light travel in a straight line. Okay, due to light travel in straight line. But now, okay, you need to look at this. So they also have green light. Okay, green light. So in this case, it's actually the shadow is formed because of the cathode ray is blocked by the cross. It means that cathode ray move in a straight line. Okay, so this is only 1 mark. Okay, only 1 mark answer. Alright, so we can give mark if you write, because for the structure question, sometimes they have more than 1 answer. Okay, but we look at the priority. Okay, shadow form on screen. Since you have green light, so the best answer will be cathode ray move in a straight line. Okay, cathode ray move in a straight line. But if you write cathode ray is being blocked by the cross, that one also can be given mark. Okay, I don't have to write because my handwriting, handwriting cikgu teruk. Okay, I'm not used to this pen. Alright, can boleh Okay. Now, the second one. Give reason why green light region is formed on screen. Green light region is formed on screen. Electron hit the screen forming green light. Cause fluorescent. Kinetic energy convert to light energy, hence fluorescent occur. Fluorescent material in fluorescent screen absorb kinetic energy from electron and convert to light energy. Okay, any other answer? Kinetic energy, electron convert to light energy. Cathode ray hit the screen, kinetic converted to light energy, cause fluorescent effect. Kinetic energy converted to light energy. Okay, all right. Now, when you see now, when we switch on S1, so you see a shadow plus the yellow light. So it means that light travel in a straight line. Okay, and when you switch on S2, you see shadow plus the green light. Okay, so that green light is actually due to the electron. Okay, electron that move at high speed change, okay, from the kinetic energy to light energy. So the answer is cathode ray collide with the screen, and the kinetic energy change to light energy. Okay, so most of you get the answer. Okay, kinetic energy convert to light energy, correct. Cathode ray hit the screen. Okay, because this is only 1 mark question. Okay, and then when you use the word kinetic, make sure you write kinetic energy. Don't just write kinetic. Okay, we want to see the word energy, kinetic energy, heat energy, light energy. All right, so can we proceed to next question? This one. Okay, C. So two magnets with opposite poles are placed at the side of the tube, causing shadow being deflected. And then tick the correct answer in box provided. So the direction of the deflection shadow can be determined by using okay, like this. If you bring magnet, actually if here they said how many magnet? 2 magnet. Actually, if you bring only 1 magnet also, you will see the effect. Okay, here since they put 2 magnet also can accept lah, but actually you bring 1 magnet also, the effect will be, you can be seen. So if you bring magnet, okay, somewhere here, okay, the shadow will be deflected. If you bring magnet somewhere here, okay, either here also can. Okay, but normally we bring the magnet somewhere here lah, either here ataupun atas ke bawah. Okay, so the shadow will be shifted. Yeah, the direction of the shadow can be determined by using Fleming left hand rule. Okay, yes. Okay, are you able to determine the direction of the shadow if you bring magnet near to this? Ada problem ke for this? Okay, if let's say got problem, I can't show you now. Maybe we try lah, huh? So let's say we place the magnet. Okay, the answer should be Fleming's left hand rule. Okay, we try. So let's say we bring the magnet here. So let's say this is north. Of course, up here will be south lah, huh? See my handwriting, teruk kan? Okay. We bring north here. So where will be the direction of which direction will the cross shifted? How do I draw? Let's say we look from here. So this is your eyes. Okay. So which direction will it move? Katakan cikgu label. Kan teruk handwriting cikgu. I'm not used to this pen. A, B, atas C, bawah D. From your point of view. Moving to the right, moving to the left. North. Okay, type your answer. If we bring magnet, just like the diagram that I draw, from the top, which direction will the shadow shifted? Can you type your answer as A, B, C, D as what I draw? From your point of view means that not from our side, but from here, from here. Okay, let's say we observe from here. A, B, okay, majority answer A. Okay, the answer is A. Okay, now, so since we are using our left hand Fleming's rule, you see now, if this is north, okay, so we assume there is another magnet down here. Okay, so if up there is north, so here will be south. So it means that if you use your left hand Fleming's rule, your pointer, okay, jari telunjuk, okay, must be pointing downward lah, okay, because up here is north kan, so down here is south. So your pointer pointing downward. Use your left hand, okay, then the current, where is current? Current will be opposite to the direction of cathode ray. So since cathode ray is moving to the right, okay, so current will be in opposite direction. Kan cathode ray is electron, right? So current will be opposite to the direction of the electron. So it means that current will be this direction. This is current. So try to shift your hand, okay, with your pointer still pointing downward. Okay, your center finger now is following current. So do you see that your thumb is following A? So the answer is A. Okay ke? Boleh faham? Boleh, ha? Alright, good. So far so good. Okay. It's okay if you make mistake. We learn from the mistake, huh? Okay, question number 2. So this is from chapter Heat Form 4. Wah, Anna happy, huh? Alright, now, so diagram 2 shows a set of apparatus used to determine the specific latent heat of vaporization of water. Okay, so this is important. Latent heat, haba pendam. Okay, specific latent heat, haba pendam tentu. Vaporization, penguapan. So the heater is labeled with this 1000 watt 240 volt. What is the meaning of this labeling? Okay, chapter electricity, form 5 chapter 2, they can ask you also, what is the meaning of this labeling? 1000 watt 240 volt. Nah, apa maksudnya? Sometimes they ask you 1 mark question, asking what is the meaning of this label? Power rating. Be more specific. When they ask you to define what is the meaning of this labeling, no matter what type of electrical appliances is that, so you need to explain what is this W, what is this V. 1000 joule, I'm reading Zheng Yang answer. 1000 joule of energy is dissipated per second when connected to 240 volt power supply. Jiaming, 1000 joule is released in 1 second when connected to 240 volt power supply. When connected to 240 volt power supply, 1000 joule of energy is released. Chloe, 240 volt rate of energy dissipated is 1000 joule per second. consume 1000 joule every second when connected to 240 power supply. Ada lagi? Okay. Consume 1000. Okay, now when you want to write joule, make sure you use capital J. If you write small j, confirm they will reject your answer. Okay? Because symbol for joule, J, should be capital J, not small j. Energy every 1 second if it is connected to 240 power supply. Okay. Semua ada keyword. Now, so when you want to define that, it's like this. So this 1000 watt. What is actually unit for power? I'm not asking you, I'm telling you that watt, W, is the unit for power. Okay, so power, right? See my handwriting shaking. P sama dengan power sama dengan energy over time. So it means that watt is the same. Okay, let's say we refer to the unit. Watt will be unit for power kan? Okay, what is the unit for power? I'm not asking, I'm telling you what is the unit for power. Okay, now the energy, the unit for energy is joule. And then T here is time per second. Right? So when you want to define this 1000 watt, you need to use this. So it means that you need to talk about energy and time. Okay, so the meaning of this label will be when the heater, so you use the instrument that is given, when the heater is connected to 240 volt power supply, it will consume 1000 joule of, you need to tell what type of energy, of electrical energy in 1 second. Okay, so it means that when, okay, cikgu ulang, when the heater is connected to 240 volt power supply, it will consume 1000 joule of electrical energy in 1 second. Boleh? Okay, cikgu type dekat okay, the answer that I type here. So when the heater, okay, you look at what is given. If they give you heater, so use heater lah. If they give you light bulb, use light bulb. Okay, so when the heater is connected to 1000 joule, okay, of electrical energy. This one need to be clear. Electrical, I'm typing in the chat box. Okay, electrical energy. Salah cikgu. So when the heater is connected to 240 power supply, 240 power supply, okay, it will consume 1000 joule of electrical energy in every 1 second. You can write per second. Okay, you can write in every 1 second. Okay, I just use shortcut per second. Like that. Okay? Boleh? That would be famous question also, selalu keluar. Alright, so now we know that 1000 is the power, P, and then 240 is the voltage. Okay, now this is the diagram. So, what is the meaning of the specific latent heat of vaporization of water? Apa jawapannya? Heat required to change state of 1 kg water from liquid to gas without change in temperature. Amount of heat energy required to change the physical state of 1 kg substance from liquid state to gaseous state without a change in temperature. Heat needed to change the state of water from liquid to gas without changing its temperature. 1 kg. Heat absorbed by 1 kg water to change from liquid state to gas state. Yes. So you see, here you see they are using the word specific. When you see the word specific, so it actually refer to mass. The word specific here, it relate to mass, means that per kilogram. So your answer must have 1 kg, mesti ada 1 kg. Okay, so latent heat means the heat that is absorbed without changes in temperature. So in BM is haba pendam. Kan terpendam means tersembunyi. Okay, so haba diserap atau dibebas tapi tak sedar because there is no changes in temperature. Okay, that is latent. And then here, vaporization changes from liquid to gas lah. Okay, so I read again, see which one is the best answer. Amount of heat energy required to change physical state from 1 kg substance from liquid to gas. Heat absorbed by 1 kg water to change from liquid to gas. Heat energy needed to change 1 kg of liquid to gas. The simple answer will be 1 kg liquid to gas at constant temperature. Chloe. Jawapan Chloe, ya. Amount of heat energy required to change 1 kg of liquid to gas at constant temperature. Yes, that is the best answer. Okay, yang lain pun boleh bagi markah. Cuma Chloe's answer is more simple lah. Simple. Tepat. Alright, boleh ha? Okay, good. So while the water is boiling, so the reading of the compression balance decreases by 0.08 kg in 120 seconds. So calculate the specific latent heat of vaporization of water. Try. Remember the power just now is 1000 watt. They give you the time taken is 120 seconds. Teacher, is it liquid or water? Sekejap, you can use water, you can use liquid. Both accept. Wow, so fast, Aurora. Okay, we wait for others' answer. What formula do you use? Okay, so 0.08 kg decreases. So it means that the water already changed to steam lah. So this is the mass of the water that already changed to steam in 120 seconds. Energy over mass. Yeah, correct, Vincent. So we are using that formula PT equals to ML. Okay, PT sama dengan ML. So PT here is actually Q lah. Okay, power times time kan. That one is Q, energy. Alright, so since there is no changes in temperature, so you use ml. So we have another formula, Q sama dengan mc theta. Kan, PT sama dengan mc theta. But this one when there is change in temperature. But now there is no change in temperature. Okay, because water change to steam. Okay, only changes in phase, no changes in temperature. So we don't use this formula. So we use this one. So the power just now is 1000. Okay, times T. If they give you in minute, make sure you change to second. Okay, now they already give you 120 second. It actually 2 minutes. So mesti tukar ke second lah. So now they give you in second already. Then okay. And then for the step here, you don't have to write unit. The mass also, if they give you in gram, make sure you change it to kilogram. Alright, so 0.08 L. Ayo, sakitnya cikgu tulis. Okay, tekan calculator. How many 0? 1, 5? 1, 5. Yeah, 1, 5. Cikgu pun nak tekan calculator. So for the answer, you don't have to change to standard form actually, since the question did not say about use tablet maybe easier. Yeah lah. Okay, I'm using Wacom, but I'm not used to this pen. Maybe because of how I write. Okay. I need to practice. Tapi cikgu malas nak practice. Okay, 1, 5. Okay, just follow. When you tekan your calculator kan, just follow lah what is given. So you don't have to change it to standard form. I suggest you to just copy what is given in on your what is shown on your calculator. Sebab sometimes student when they change to standard form, they change it wrongly. So sayang lah, sayang markah. Okay, so here will be 1, 5. How many 0? 5, 0. Okay, like that. So the step here, when you substitute, so this is the first mark, and then your final answer, like this can give mark or not? Like this, can give mark or not? Cannot, no? Because physics, your final answer must have unit. So what is the unit for L? Okay, from here can see already, Q over energy over mass. So it means joule per kilogram. Right, joule per kg. Okay, so far so good. Can continue. Oops. Okay. Okay, next question. Explain why at the boiling point the temperature of water remain unchanged but the state of matter changes from liquid to steam. 2 marks. Give reason lah. Why at the boiling point the temperature of water remain unchanged. Temperature no changes. But the state of matter changes from liquid to steam. Two marks. So it means that 2 points. Heat absorbed used to overcome the force of attraction between the particle to change its state from liquid to steam. That is the first mark. Okay, Aurora, that is 1 mark. So the first mark, okay, tick 1 is actually talking about the force. So it means that the heat absorbed is to overcome the force of attraction between the molecule. Since we have 2 marks here, so that is only 1 mark. The second mark. Heat absorbed used to overcome force of attraction. Sama. Okay, Jason, your answer is the same with Aurora. Heat absorbed used to break bond between water particle, change to liquid to gas. Okay, that is one mark. Kinetic energy of water particle do not increase. Yes, the second mark is related to the kinetic energy. Kinetic energy. Okay, so the first mark is given when you write your answer. The heat energy is used to break to overcome the force of attraction between the molecule. Second mark, when you talk about the heat energy. Okay, so in this case, the heat energy, the kinetic energy, sorry, kinetic energy unchanged. Okay, because the if let's say the temperature, when the kinetic energy increase, temperature will increase. But when there is no changes in kinetic energy, so the temperature will be constant. Boleh? So only two marks. No other answer accepted. Only these two. One is the force of attraction. The other one is kinetic energy. Okay, question number 3. Okay, cikgu ajar perlahan because I don't know, because macam different student have different phase, right? Different speed. So cikgu bawa perlahan-lahan lah, alright? So if you have any question, just ask, okay? Now look at question number 3. So this is from chapter wave, form 5. So diagram 3.1 shows two pulse of wave with amplitude A. Normally we use capital A, but this question using one small a pun boleh lah, amplitude. Amplitude A produced from vibrating of slinky spring P and Q respectively moving towards each other. Okay, so means that the two, so we have slinky spring P here, okay, and then slinky spring Q. And the two pulse is moving towards each other. Maksudnya macam bersambung lah. Okay, moving towards each other. So means that moving like that. So they don't draw the arrow, but you should know that they are moving towards each other. Now, so what type of wave actually produced by that slinky spring? Apa jawapannya? What type of wave is produced? Pandai. Yes, betul, Apip. Correct. Transverse. Okay. Wah, semua betul. Clap ya, clap your hand. Okay, betul. Yes. Okay, because there are two type of wave. Okay, one is transverse, the other one is longitudinal. So in this case, actually slinky spring can give you both type of wave. It can give you transverse, it can give you longitudinal. Depends on how you vibrate, okay, the slinky spring. So in this case, since you move the slinky spring sideways kan, like that, so this is transverse. Okay, good, betul. Alright. Okay, next. So diagram 3.1. On diagram 3.1, sketch the shape of the slinky spring in box R to show the resultant, okay, resultant of the pulse. So you need to draw the shape, sketch the shape of the slinky spring in box R to show the resultant of the pulse. Okay, how is the resultant of the pulse? Okay, cikgu bagi pilihan lah. Adakah jadi macam just like this? Is it like this? I put here as number 1. Same as this. Or number 2. Same as this one. Ataupun like this. This is number 3. Ataupun like this. Number 4. Apa jawapan? Okay, betul. Number 3. Okay, why number 3? Why number 3? Pandai. Bun pandai. Yes, betul. Macam M. Okay, good. Why the shape is like that? Destructive. Okay, yeah. So this one will be crest meet with trough. So the two wave will be cancelling each other. So this that will be destructive interference. Alright, gelombang interference memusnah. So the amplitude will be 0. Okay, good. 0 amplitude. State the value of amplitude. Oh, macam tahu soalan. Alright, so state the value of amplitude. That will be 0. Okay, 0 amplitude. Okay, good. Okay, next one. So diagram 3.2 shows the pulse of vibrating slinky spring. The velocity of the pulse given 24 centimeter per second. Okay, 24 centimeter per second. Then they give you this diagram. Then they ask you to calculate the frequency of the pulse. Should we write 0 or 0? Okay, honey bunch, both accepted. Okay, both accepted. You can write 0, you can write kosong, symbol, number pun terima. Okay, try this question. 4 hertz. See how many marks? 2 marks, okay? Okay, what formula should we use? What formula? V sama dengan? Yes. Oh, there is a symbol, Aurora. Cikgu pun tak tahu ada symbol like that. Boleh type, Where you get the symbol? Yeah, symbol for lambda. Where you get it? Okay. Oh, ada. Is that Chinese character? Tak lah. Chinese character is different bah. So, kejap. Lambda. If you write lambda, it must be like this, This one is correct, This lambda. Don't write like this. This is the Chinese character. This one salah, Okay, so don't write lambda like this. Okay? This one salah. Wrong. Should be this. Okay. Now, so we use this formula. V sama dengan F lambda. So make it a habit to write the formula first. And then we know that the velocity is 24, kan? So the velocity is 24. 24, they ask you to determine the frequency. And then, what is lambda? So here, this 12 cm is actually 2 lambda, sama dengan 2 lambda. Kan? Crest to crest is 1 lambda, and then another one, so means that this is 2 lambda. Alright, so lambda will be sama dengan 12 divided by 2, so you get 6. Okay, it's either you write here 12 divided by 2 pun boleh, ataupun you write lambda berasingan like this also can. You solve it. So this will be 1 mark here. And then your final answer, 12 divided by 6, it will be 4. Mesti ada unit ingat frequency mesti ada unit. The final answer mesti ada unit lah. So hertz. Alright, so this is mark number 2. Okay, good. So far so good. Okay, D now. So what happened to the frequency of the pulse when the speed of the vibration of Slinky spring increases? So what happened to the frequency of the pulse when the speed increases? So jawapan, this is 1 mark. So you just write either increase, decrease, equal. Yensem, 4 or 4.0? Both accepted. Okay, both accepted. Boleh, 4.00 pun tak ada problem. Okay, yang penting mesti ada unit. Alright, now look at D. Apa jawapannya? Increase. Okay, I'm reading. Cikgu tunggu jawapan yang lain. Semua increase kah? Increase if wavelength constant. Increase. The speed, you imagine, speed of vibration. Here, you imagine, you vibrate this faster. So what will happen to the frequency? Jason answer as increase if wavelength constant. Can the wavelength constant if you increase the speed of the vibration of the Slinky spring? No, yes, cannot, betul. So jawapan will be increased lah. So the frequency will increase because why? The lambda will be smaller. Okay, lambda will be smaller. If you increase, if you vibrate this faster, so the lambda will become smaller. Means that there will be more vibration in 1 second. Okay, faham? Okay, so the answer here will be frequency increase. Velocity constant. The question said the speed of the vibration increase. Okay. Don't confuse with refraction. Katakan water wave travel from deeper region to the shallow region ataupun from shallow region to the deeper region. So the velocity increase. Frequency sama, lambda bigger. That is a different way. That is different because that is refraction. This one is the Slinky spring. You vibrate the Slinky spring. Okay. Now move on. Number 4. Okay, number 4 shows baseball pitcher ready to throw a ball. So showing the second diagram shows spinning of the ball after being thrown. Okay, nampak eh? So this is the spinning. So the spinning will be like that. Okay, and then the direction of the airflow. Direction of the airflow. Sama lah. Okay, so this is how the ball is being spun. So diagram 4.1b, mark region P. Mark P, the region where the speed of the airflow is higher. Speed higher. Speed of the airflow is higher. Okay, cikgu letak number. Okay, atas ke bawah? Atas, bawah, kiri, kanan. Above the ball. Ada jawapan lain? Up there. Okay, ada jawapan lain? Atas. Mitsuki disakiti, kesiannya. Atas. Atas bola. Yes, atas. Why like that? Why atas? Apa soalan seterusnya? Indicate with arrow to show the direction of the path of the ball move. Okay, so first you need to label where the speed of airflow is higher. So now you see the spinning is like that, right? So when the ball is spinning like this, So means that here also arrow like that, huh? And then here will be continue like that. So you look at the direction of the ball spinning and the air. So if they have same direction, so it means that the air there will be at high speed. So it means that here will be higher speed, faster up here. But here you see the spinning of the ball is focusing on this part is opposite to the direction of the airflow. So you imagine if let's say opposite like that, of course this airflow will be moving at slower lah, lebih perlahan. Okay, so the answer will be here. You label here as P. They ask you to label P kan? The question said label with P. So label dekat atas with P. Okay, correct. Next one. So indicate the arrow. Indicate with an arrow to show the direction of path ball move. What is the direction? Cikgu padam this one first. So here just now, P, we label here as P. Direction, go up. Yes, why go up? So the direction can be straight up, aduh, ataupun sengit like that pun terima. Okay, as long as upward. Okay, jangan turun bawah. Alright, why up? Adakah soalan seterusnya? Explain your answer, 2 marks. Why the direction is up? Because they ask you explain your answer in A2. So this question lah. Okay, why the direction is upward? Pressure is lower above the ball. This is 2 marks. Okay, pressure is lower above the ball. Boleh terima. Okay, Bernoulli's principle. Okay, the question asking about why. Bernoulli's principle will be this one. Okay, name the physics principle involved in B1. That will be Bernoulli's principle. So spelling make sure correct lah. Okay, jawapan Jason betul lah for this one, Bernoulli's principle. But the explanation, difference in pressure. Okay, lagi. Pressure is higher at below. Okay, so mark 1 for this. Tick 1. When you talk about pressure, so pressure above, you need to write complete. Pressure above is smaller compared to pressure below. That is the first mark. Okay, pressure above is lower to pressure below. So means that if you write pressure above is lower or pressure below is higher, markahnya sama. Then kejap, another mark that can be given also will be there is a difference in pressure. Okay, difference in pressure. So ada perbezaan tekanan. This one can be given also. Mark 2. Okay, another mark will be, what do you think? Good, Ashraf. Yes, resultant force. So there is a resultant force. Net force terima. So means that mark number 3 will be for the net force. Daya bersih wujud. Okay, that is how we give mark. So no matter how you write your answer, so we will look at these 3 points. Okay, the first one will be pressure above smaller than pressure below, and then there is a difference in pressure, and then net force is produced. Okay, good, bagus. Okay, boleh tahan. Okay, next one, next question. So diagram 4.2 shows a 0.14 kg 0.14 kg baseball reaches a batter with a speed of 30 meter per second. So physics, you better look at the unit carefully. Kadang-kadang they simply give you macam gram ke ataupun centimeter per second ke. So more focus more on the unit on. And then the bat make contact with the ball for 0.082 seconds. Okay. Now the question, so what is the force? What is the force applied by bat if ball move away with a speed of 43 meter per second? Okay, try. So calculate the force. What type of force is that? What is the name of the force acting? Yes, good. Impulsive force. Betul, daya impuls. Calculate. Wah, now we have 100 student lah. Wah, boleh tahan you all. Cikgu pun tak sangka there are 100 student tonight. Cikgu ingatkan maybe 10 or 20. Paling-paling banyak pun 30. So this is exceeding my expectation. One to 4.63 Newton. Yes, physics is fun. Betul. Okay, good. So if like this, we can have more. We can have more live session. Hopefully what we discuss come out in your exam. Hopefully. 22.195. 22.2. Okay, so we have huge gap between Vincent answer and Jason's. I mean, okay, write your answer. So I see Jason and Aurora have the same, nearly the same answer. Aurora, you round off to 1 decimal place. So when katakan, let's say Jason's answer is correct, it's good to write your answer at least in 2 decimal place. Okay, at least 2 decimal place. 2 to 4 decimal place selamat. So I'm waiting for some more to write your answer. Oh, somebody ada yang tulis 51, 51.22. Farah. Okay, Zenyang, Chloe, 124. So which one is the answer? We have 3 answers now. What formula do you use? The impulsive force formula. So it means that F sama dengan mv minus mu divided by t, betul. So this is the formula lah, mv minus mu divided by t. So the mass is the same. Okay, so you need to visualize the movement of the ball first. The best ball reaches the better. So it means that first, katakan, let's say from here lah. So the best ball move towards the better. So this is, the speed is 30 meter per second. Then after that, the ball move away with a speed. So move away, so bounce back like that with a speed of 43 meter per second. So do you see that the velocity now, they are moving now, the before and after. So the ball is moving in opposite direction. Kan? So when like this, okay, one should be positive, the other one is negative lah. Okay, so to make it easy, so we use after positive and then before opposite direction we put negative lah. Okay, so means that when you substitute in your calculation, when you substitute in the calculation, okay, so here will be 0.14, okay, cikgu buat kurungan terus lah. V now is 43 minus initial velocity in opposite direction, so we put there, mesti ada negative. Okay, and then divided by T. T is 0.082. Okay, tekan calculator. Vincent dah happy dah. Okay, clap to Vincent. Betul lah. So careful ya. Bukan common mistake here. Normally student forgot that the direction. Okay, so normally you forgot to put negative here. Bila you forgot this, memang jadi salah lah. Okay, it should become 43 minus negative 30. So means that here will be plus. Okay, so the answer is 124.63. Boleh ha? Don't forget the unit lah. Unit mesti ada. Okay, Newton. So the answer here is 124.63 Newton. Okay, mesti ada unit. Okay, so ramai dapat jawab kan? Macam biasalah, in term of mark will be the step here will be 1 mark, and then your final answer will be 1 mark. Okay. Chapter light. So this is concave lens. So ada yang request, teacher please do for form 4 KBSM live video. Maybe one day, okay, cikgu want to focus on form 5. Just like my student in SMK Batu Lintang, they will be having more exam in 2 weeks time. Actually dah having more exam, but then we have our PKPP, right? So will be postponed lah. Okay, so we focus on form 5 first, but form 4 also can join us. Some of the topic is already you have learned in your form 4. Okay, so diagram 5.1, 5.2 shows focal length of 2 concave lens. So both concave lens have same refractive index. Okay, same refractive index. When they say have same refractive index, means that they have same material. So the optical density is the same. Okay. What is the question? Tick the correct answer in the box provided. So, formula, diopter. P, the power of lens P in the unit of diopter can be determined by, we know this is the formula for power. P sama dengan 1 over focal length. Okay, P equal 1 over focal length. But if let's say you want your answer to be in diopter, diopter is the same as per meter. Diopter, this unit, diopter here sama dengan per meter. Okay, so the answer is obvious. Kan? Tapi kan, when you write for power, unit per centimeter also accepted lah, because if you use centimeter, so the unit for power will be per centimeter pun betul. Okay, this is unit for power per centimeter. And then per meter also unit for power. But if they ask you about diopter, you must use meter. Okay, observe diagram 5.1, 5.2. So this is common pattern for the question. For question number 5, they normally give you 2 diagram. And then from that 2 diagram, they normally will ask you to observe. After you observe, they will ask you to compare. Sekejap. Apa kata cikgu? You observe, okay. you need to compare lah. After, when you observe and you compare. You see, compare, compare. After they ask you to compare, then they will ask you to relate. Okay, kejap I think the another. Okay, this question also the same. Question number 6. The pattern is the same. You see, they give you two diagram. Then you see, here they quickly ask you to compare. After compare, see, they ask you to relate. Kan? So how do we answer this? So when they ask you to compare, compare doesn't mean the difference only. Comparing, it can be the difference, it can be the similarity. Now, look at this. Compare the thickness of the lens. Obvious. .2 is? Write your answer in the chat box. .2 is thicker. Yes, betul, betul. Okay, yes, betul. So 5.2 is thicker. 5.1 is thinner. Okay, semua betul. So here, compare the thickness of the lens. So you can write 5.2 is thicker. Ataupun 5.1 is thinner. Ataupun you can tulis macam siapa? Let me see. Jason, Vincent, Chloe, Cheng Hong, Zeng Yang, Boon, semua betul. You can also use that symbol. Okay, mathematics symbol, but make sure you write it correctly ya. Ya, Mitsuki disakiti pun betul. Okay, next one. So compare the focal length f of the lens. Focal length. Nah, nampak kan? From the diagram also can see. Diagram 5.1 is longer. 5.2 is shorter. Okay, correct. Okay, semua betul. Okay, so the focal length for 5.1 is longer, 5.2 is shorter. So cikgu tulis here. Alright, so first just now, thickness. Okay, thickness. Thickness 5.2 is thicker, okay, compared to 5.1. And then after that is the focal length. So focal length of 5.2 is shorter compared to focal length 5.1. Okay, next question. So relate the thickness. Okay, you see the word relate. After the word relate, there will be two physical quantity. It will be followed by two physical quantity. So now we have thickness of the lens and the focal length. So when the question asking you to relate, you write your answer as if you are writing a hypothesis. Maksudnya, okay, if you katakan the question asking you to relate, ingat when the question asking you to relate, your answer will be just like when you write your hypothesis. It means that you need to use the word the greater this, the greater that, ataupun the greater this, the smaller that one. Okay, so thickness and focal length kan. So from here, okay, cikgu ajar teknik. So here can see, okay, like that, right? So means that thickness. So this one lebih besar. And then here, this one lebih kecil. So you can use this This part. This is how you relate. You can write the greater the thickness of the lens, the smaller the focal length. Okay, so without referring to any diagram. Okay, so the greater the thickness of the lens, the smaller the focal length. Ataupun you can write the thinner the lens, the longer the focal length. Pun boleh. When the kejap increase focus on technique, increase cikgu Sharifah pun ada support lah. Okay, Zeng Yang, increase when can use increase, boleh, can also. Okay, when the thickness of the lens increases, the focal length decreases, pun boleh. Tapi jangan guna perkataan dependent. You don't write the focal length dependent on the thickness. That will be wrong. Boleh? Okay, semua hebat-hebat. Name the light phenomena. What phenomenon is this? What phenomenon? This one will be? Good. Betul. Refraction. Ejaan make sure betul Jangan salah You don't write refraction like this. Okay, jangan tulis reflection. Okay, jangan salah eja. Because if like this, macam sebab reflection, ejaannya hampir sama. So, if you use E here, salah lah. Okay. Pembiasan cahaya, betul. Okay, good. Teo Jia Ming. One extra question. If for depth of water, can we use depth of water increases, decreases? Depth of water increases. When the depth of water increases. Can. Depth of water increases means lebih dalam. Depth of water decreases means lebih cetek. Boleh, can. Depth of water increases. When the depth of water increases means that lebih dalam. Betul lah, betul. Ada lagi soalan? Do we need to write refraction of light? This one will be refraction of light. If you write refraction only pun boleh terima. But katakan here you write refraction of sound. This is not sound. They will reject it. Okay, so selamat if you just write refraction. But here memang this is memang refraction of light lah. Okay. Ya, pembiasan cahaya. Betul. Teacher state the relationship relate using same technique. Sama, same. State relationship or relate, it is using the same technique. Means that you need to write as if you are writing a hypothesis. You can use the word when this increase, this one increase or increase decrease, ataupun greater smaller. Boleh. If the question is about mirror, if mirror will be reflection, betul. Okay. Yes, any more question? Okay, good. Good that you ask. Cikgu pun suka nak jawab. Because if you ask, then I know which part you need more explanation. Okay, we proceed. Ray diagram. Selalunya, in some reference book, they say direct. Oh, okay. If the question asks you to relate without showing any graph, your answer will be as if you write a hypothesis. But if let's say they give you graph, then your answer must be specific, either directly proportional or increase or inversely proportional or increase linearly, decreases linearly. Okay, if they give you graph. If no graph, just like this question, just write as if you are writing a hypothesis. Clear? Boleh? Okay, good. Zeng Yang, good question. Ingat, if they give you graph, just like paper 3, that one mesti specific. Okay, you need to write directly proportional, inversely proportional, and so on, if they give you graph. If no graph is given, enough you write as if you are writing a hypothesis. Okay. Alright. Ray diagram. Selalunya ray diagram in cikgu boleh kata every year come out. Okay, ray diagram every year come out. But since you know that paper 3 kan, chapter 5 light, we have reflection, we have refraction, total internal, reflection, and also lens. Okay, so mana-mana diagram can come out lah. Okay. Okay, so how to draw ray diagram here? Ada masa we will focus on only drawing ray diagram. So this is concave lens. Okay, so like selalunya cikgu suka sambung terus. Okay, from here sambung, and then here will be diverging like that, as if they come from the focal point. So use dotted line because this is as if. Okay, as if from the focal point. Cahaya sebenar will be this line. We use solid line. Then the second ray from the head of the object to the optical center. Lurus because optical center macam normal line lah. Okay, like that. So this one lurus, solid line. Okay, so nampak persilangan here. If you lengthen this, the first ray, one mark, first ray, second mark, second ray. If you lengthen the first ray and the second ray, it will not intercept. So look here, belakang. So this is the intercept. So can use, actually we use dotted line lah because the image is virtual. So this is the image. So you draw the image. So this is mark number 3. Jelas? Boleh? Okay. So ada masa we will focus on only ray diagram. Okay, start from 5.1 reflection sampai lens. If sampai lens, then we can also draw ray diagram for the telescope and also microscope. Okay, but not tonight lah, huh? Question number 6 now. So diagram 6.1, 6.2 shows two electrical circuit, konstantan wire X and Y, same length, sama panjang. So the current flow in both diagram the same. Okay, nampak pada oh, the emitter. Nampak kan emitter? The pointer is deflected, same size. So means that the current is the same. But the voltmeter nampak ada beza. Then the wire pun nampak ketebalan lain. Okay. So what is the meaning of current? Teacher, do we lose mark if we didn't differentiate between dotted and solid line? School level, okay. How do I explain how? If possible, draw in the correct way. Okay, I'm answering Hannah question. Hannah Farisha. So do we lose mark if we didn't differentiate between dotted and solid? So it's good to follow the correct method where the real light will be solid line. Okay, as if the light will be dotted line. Tapi in SPM, okay, as far as I know, they will still give mark. Okay, if you draw all solid line ataupun all dotted. Tapi ilmu yang sebenar, we differentiate between solid and solid line lah. Solid line and dotted, because the solid will represent the real light, cahaya yang sebenar. Okay. Okay, now we are talking about current. Rate of flow of charge. Betul lah. Okay. Current. Formula for current is from this, right? So Q sama dengan IT. Q sama dengan IT. So I sama dengan Q over T. Okay, so I sama dengan Q over T. If you write like this, can or not? Can give mark or not? If you write just like this, no mark. Okay? If you write like this, I sama dengan Q over T, they don't give mark. Why? Because we don't understand Q, we don't understand T. So you should write, okay, where Q is charge flow, T is time. Then only can be given mark. Faham? Ataupun jawapan yang lain semua kat atas lah. Vincent, Jason, rate of flow of charge. That one semua betul. Okay, Chang Hong semua betul. Okay, ataupun because time here, okay, means that rate lah, bahagi masa kan. So rate of flow of charge. Q is flow of charge. Iconic. I sama dengan V over R. That one we don't accept. Okay, this one kita tak terima. I sama dengan V over R. Sebab apa? So this is actually for ohmic conductor, kan? Ohm's law, V sama dengan IR. So we don't accept this. Okay, so current yang that we accept will be this formula. I sama dengan Q over T. Ingat rate of charge flow. Betul. Okay, so based on diagram 6.1, 6.2, compare reading of ammeter. Kan jawapan dah ada tadi. Here, reading of ammeter. So current, the same. So here should be, you write the same. Thickness of wire X and Y. Mana lebih tebal? Y. You can say Y is thicker. Ataupun X is thinner. Okay. Boleh So here will be, cikgu guna simbol lah. Okay, so here 6.1 sama, equal ataupun equal. Ataupun the same. Okay. Can you write constant or not? Jangan tulis constant Constant salah. Alright. Constant doesn't mean that they are the same. Okay, you either write equal ataupun the same. And then thickness of X and Y, so Y is thicker. Y thicker. X thinner. And then reading of the voltmeter, mana lebih besar? 6.1 is more. Okay, so 6.1 is bigger. So reading of the voltmeter, so 6.1 greater than 6.2. Then relate thickness and the potential difference. So you can see the thicker the wire, here boleh nampak, the thicker the wire, the smaller the potential difference. Okay, relate thickness and the potential difference. So the thicker the wire, the smaller the potential difference. Okay, good. Betul. Correct, Aurora. Ataupun the greater the thickness of the wire, the smaller the potential difference. Okay, correct. But when you write your answer for this type of question, relate, you don't talk about the diagram anymore. You don't write your answer as, jangan tulis like this. Referring to diagram 6.2, when the thickness of Y is thicker, the voltmeter reading is smaller. Don't write like that. Jangan relate to the diagram anymore. Because why? When you write this question, relate, it should be a general statement for any situation that involve thickness and potential difference. It means that you don't relate to the diagram anymore. Just write about thickness and potential difference. Clear? Okay, jelas, Okay, good. Next. State one other physical quantity which influence resistance of the constantan wire. One other physical quantity. What is physical quantity? Quantity that can be measured. One other. Because why? Here, we are talking about thickness. Okay, about thickness means that the diameter, the cross-sectional area of the wire. So, yes, correct. Length, betul. Ada jawapan lain? Temperature, correct. Yes. Length boleh, temperature boleh. Diameter, can you write diameter? Haziq? Okay, can write diameter or not? Cannot. You cannot write diameter anymore because the question already relate to diameter. So means that the diameter, the cross section, maksud yang sama lah, thickness, diameter, cross sectional area. Okay. So that one semua sama, already influence here. So you need to write other than diameter. Sama, Vincent. Okay, sama. So since here the thickness of the wire influence, right? The thickness of the wire influence the resistance. You don't write about thickness anymore lah. Same meaning as thickness will be diameter, cross-sectional area. Okay, so the answer that we accept here is the length and also temperature. Now what about type of material? Type of material, is it a physical quantity? Do they have unit or not? Because we're talking about physical quantity. So try to avoid type lah. Walaupun type of material, yes, it affects resistance. Yeah, so better not to write for this question. Okay, because you have other answer. Okay, ada length dengan temperature. That will be better. Okay, jangan tulis type. Even macam paper 3 pun, the variable kan, sometimes student love to write constant variable, type of something. So try your best not to write type. Okay, tulis something that can be measured. Refer to your chapter 1 form 4. Okay. Okay, next question. So another constantan wire Y put parallel in the circuit as shown in diagram 6.3. What happened to the reading of the voltmeter? 1 mark only. Satu markah. So wire Y, same diameter, placed parallel, shown in this diagram. So the current sama, magnitude of current is the same. Now they ask you what happened to the voltmeter reading. Increase ke decrease? Ada jawab decrease, ada jawab increase. So we wait for some more answer. Ada reason kah? Do they ask you? Yeah, they ask you reason. Give one reason for your answer. If you write decrease, then you write what is the reason. Voltmeter reading. Smaller effective resistance. Resistance decreases. Smaller effective resistance. Effective resistance, circuit decreases. Okay, so V ya, voltmeter reading V sama dengan IR. So the current will be constant, kan? Sama macam just now, right? Okay, now we have two wire like that. Okay, so it means that the effective resistance, okay, will be this will be smaller. So when the effective resistance is smaller, so the voltmeter reading will be smaller also. Okay, semua betul. Good. Yes. So the voltmeter reading decreases. So here, macam soalan structure kan, you don't have to repeat you don't have to write macam like this. You don't have to write the voltmeter reading decreases. Just tulis decreases cukup. Okay. Tak perlu ulang. Don't waste your time. Don't waste your ink. Don't waste your energy lah. Okay, tulis decreases cukup because the question straightforward, asking about the voltmeter reading decreases. And then reason. So you cannot just write resistant here. Okay, jangan tulis resistant only. So it should be effective resistant. Okay, ataupun total resistant. But the best term will be effective resistant. Okay, effective resistant decreases. Okay, boleh ha? Zeng Yang, don't write resistant only. This is the effective resistant ataupun total resistant. Clear? Jelas? Now it's already 10:30. We already finished question number 6. Do you still want to continue? I check how many now. Ada yang dah tidur kah? Oh, already tinggal 86. So these are the yang sangat bersemangat lah. Just now we have 100 kan? So it means that already 14 tidur. Alang-alang, okay. Okay, right. Question number 7. What is the difference between resistance and effective resistance? Resistance will be referred to only one resistor. Effective resistance will be referring to the whole circuit. Okay, keseluruhan. Okay, so you should be using effective lah, keseluruhan. Okay, we continue. Question number 7. Number 7. A stiff copper rod is placed in between opposite poles of a permanent magnet. Okay, permanent magnet. So we have south pole and north pole. So this is the stiff copper rod. So look at the diagram carefully lah, because physics macam science subject, they have a lot of diagrams. So look at the diagram carefully. Look at the labeling also. So look at the question. So what will happen to the copper rod when switch is on? The question asking what happened to the copper rod when switch is on. Ada satu markah. Swing to the right. Ada jawapan lain? Move to the right. Swing to the right. Ada lagi jawapan lain? What law do you use? What rule do you use? Push to the right. push to the right, move to the right, deflect, swing to the right. Okay, what rules do you use to determine the direction of the stiff copper rod? Fleming's left hand rule. Okay, good. Now, so obvious you know how to use Fleming's left hand rule. So if you see battery, the power supply in the circuit, just like this kan, ada power supply here. So means that you need to use left hand rule lah. But let's say there is no power supply, tiba-tiba ada galvanometer without power supply. It means that the motion produce current, that will be right hand rule, like right hand Fleming's rule. So this is left hand. Now katakan switch on. So it means that current will be moving like this from positive to the negative. Okay, go like this, masuk here, turun bawah. We focus on this part. Okay, and then current naik atas kan, and then complete the circuit lah. But we focus on this part. Okay, this part only. So it means that now current is going that direction. So senang cikgu kata going in now, ke dalam lah. So if ke dalam, what is the symbol of the symbol that we use? Dot ke X? X atau dot to represent current going in? X. Okay, good. Betul. Okay, macam Robin Hood arrow Robin Hood kan, like that. So belakangnya kan macam ada bulu ayam, like that. Like that, right? So let's say current is represented by the arrow. Okay, so if let's say mata kita di belakang like this, okay, arrow ke dalam kan, arrow bergerak ke dalam, so we will see this part X. Katakan our eyes is here, so means that the arrow current going out lah, maksudnya current ke arah mata kita, we will see this part only dot. Okay, that is how you memorize the symbol lah. So means that X here means current going in. Okay, dot means current going out. Aduh, handwriting cikgu. Okay, current going in, so it means that X. So use your Fleming's left hand rule. Current going in, atas south, bawah north. So your pointer pointing up, your center finger going in, so the deflection will be to the right. So this is the force. Okay, betul lah. Jawapan semua betul kan? Alright. So it should be swing to the right. Okay, jawapan is swing to the right. Ataupun move to the right. Ataupun deflect to the right. What if you write your answer as deflect only? Boleh bagi markah ke? If you write deflect only, no mark. If you write bergerak sahaja, also no mark. Okay, sepatutnya bergerak ke kanan. Explain your answer. Wah, explain your answer. Oh, susah ha. How to explain? Okay, check. If essay, we give mark also for the diagram. On diagram 7.2, draw resultant magnetic field produced. Oh. Interaction between magnetic field and current result in resultant force. Okay. Magnetic field of the current carrying conductor interact with the magnetic field of the permanent magnet, producing catapult field. A couple of force is produced to move copper rod. Copper resultant. Oh, okay. Ada jawapan lain? Okay, resultant force is 1 mark. Another mark is the interaction of the two magnetic field. Bagus. Okay, the interaction of the two magnetic field. Okay, good. So jawapan Vincent perfect. See, magnetic field of current carrying conductor interact with the magnetic field of the permanent magnet. That is 1 mark. Okay, cikgu baca in the chat box. Okay, so magnetic field of the current carrying conductor interact with the magnetic field of the permanent magnet. 1 markah. Produce catapult field and resultant force is produced. So markah kedua will be for the resultant force produced. Okay, good. Okay, cuba lihat jawapan Aurora. Interaction between magnetic field and current. Interaction between magnetic field and current. That one tak ada markah. Sebab apa? Interaction between magnetic field of the real magnet and magnetic field of the current carrying conductor. Baru markah 1 markah. But here result in resultant force. So 1 mark for the resultant force. Boleh Semua pandai, semua pandai. Okay, good. Okay, so on diagram 7.2, draw the resultant magnetic field produced. Resultant magnetic field produced. It means that the catapult field. Okay, but they already draw this home. Okay. Now, apa perlu tambah? So I made a video on drawing the resultant magnetic field. You can look at my Fun Physics World video. I made a video for this in very detail lah. I believe if you watch the video betul-betul, you should be able to draw the catapult magnetic field. Kejap. So here we north south. Can you determine what is the direction? Sama ke the question? Sama dengan soalan ke? North, bawah, south. Oh, sama. Current going in. Okay. So we know now that the conductor is moving to the right. Okay. So we already know the conductor is moving to the right. If it moving to the right like this, so we know that this side, sebelah kiri, will be stronger magnetic field compared to the right side. Okay, that's why the conductor is being move to the right. So you can tambahkan here, add in the magnetic field lines. When you draw the magnetic field lines, make sure it does not intercept. Okay, jangan bersentuh. Sebenarnya cikgu nak lukis lagi. I want to draw more here, tapi dah bersentuh. Jangan lukis bersentuh. Jangan ikut cara cikgu. Salah. Tak boleh bersentuh. So the magnetic field here should be does not intercept. And then here tambahkan 1 cukup lah. See, bersentuh lagi. Jangan bersentuh. Alright. Then 1 mark only. Sepatutnya ada arah. Selalunya we have 3 marks here. Normally we have 3 marks for this diagram, where the first mark will be for the pattern, second mark for the direction, north, south, so direction will be up like that. Okay, and then the force. Teacher, can I draw it overlap with the circular magnetic field lines of the conductor? No, cannot be overlap. Tapi yalah, selalunya if this question come out, they will not draw like that. Selalunya it will be like this. Okay, south, and then bawah north. Okay, so they will just give you, katakan X. They will just give you like that. You complete it. At least berapa line? At least sebelah kiri, sebelah kanan ada nampak perbezaan bilangan line. Teacher, the 2 lines can sama? What do you mean? J, the 2 side line can the same? Sebelah kiri kanan, no, mesti nampak perbezaan. Contoh like this kan, cikgu dah lukis like this. So we know that the conductor moving to the right. Okay, so I know here mesti lebih banyak line. So I can draw ke kanan sedikit lah here. So that I can have more space to draw. Kan? Draw like that. So can have more space to draw. At least ada 3 sebelah kiri, 2 sebelah kanan. Okay, like this also they accept already lah. Mesti ada perbezaan. At least ada beza lah. Okay, 3 kiri, 2 kanan accept. Okay, arrow north south like that. So if they already draw line di tengah, jangan intercept lah. Alright, good. Here is only 1 mark. Kedekut lah markah. Patutnya at least 2 marks here. Okay, proceed. Next question. So diagram 7.3 shows a moving coil ammeter to measure direct current. So the ammeter in diagram 7.3 needs some modification to be more efficient. Suggest 2 modifications to be done based on the following aspect: shape of the permanent magnet and the reason, number of turns of coil and reason, and the material of core use reason. So this one macam section B dengan section C kan, but they have it in structure. Make table. Haziq, what do you mean? Buat table. This one, you just write your answer here. No need to write table. Yeah, section B we use table, correct. Ada masa we look at section C and B lah, B and C. Magnetic field more concentrated. Okay, we look at this first. Shape of the permanent magnet, C shape. Okay, C shape boleh terima. Can accept ataupun you can write. Kejap, do they have C shape? Okay, this is macam rectangle cuboid lah. Okay, so jawapan C shape accept. Circular shape. Radial shape is better. Circular shape. Circular shape boleh terima, can accept. Okay, but you see when I keep on repeating, maksudnya that answer, when the marker mark your paper, they will also do the same thing. They will think first to give or not to give. So selamat will be if you write radial shape, circular, concave lah, concave shape ataupun C shape. Okay, and then reason will be you use radial magnetic field. Okay, so the shape boleh tulis C shape, boleh tulis concave shape. Okay, concave C shape. Correct. And then reason will be produce radial magnetic field. Okay, reason we use radial so that radial magnetic field will be produced. So that the magnetic field will be focused. Boleh terima. Yeah, correct side. Produce radial magnetic field. Next one. Number of turns. More number of turns. Okay, more number of turns. Reason? Increased strength of the magnetic field produced. Betul. Yes, Vincent correct. more number of turns. Reason, to increase the strength of the magnetic field. Aurora, more number of turns, produce stronger resultant force. Stronger resultant force. Boleh. Can. Stronger resultant force. Can accept. Okay, tapi yang senang will be stronger magnetic field lah. Material of core use. Okay, look at soggy meal. More cutting of magnetic flux. More cutting. Okay, don't confuse. So here, more number of turns. There is no, we are not talking about cutting of magnetic flux because this is not generator. Okay, soggy. If let's say generator, then we look at, we will focus on the cutting of the magnetic flux. This one is Fleming left hand rule. Okay, so the interaction of the two magnetic field produce force. Okay, so the material of core use should be, yes, soft iron core. Soft iron core. Reason, betul, magnetized and can be magnetized and demagnetized easily. Correct. Betul. Semua betul. Okay, so material will be soft iron core. Reason, can be magnetized and demagnetized. Sebab apa? So this pointer should be able to go back to zero quickly and then give reading. So if let's say you are not using soft iron core, so when there is no current, so it will be macam susah nak demagnetize. So maybe it will still show you reading. Okay, if you use soft iron core, when current go in, this one will be magnetized, so there will be resultant force produced kan, it will deflect. When there is no current, it will quickly go to zero. Faham? Iron core produce more concentrate magnetic field lines. More concentrate magnetic field lines pun betul juga. Alright, can also, yeah, when you use soft iron core, the magnetic field will be concentrated, denser magnetic field pun boleh terima. Boleh Zeng Yang, can. Okay. Okay, now it's already 11. Cikgu pula yang dah mengantuk. I think you all pun tired kan? So question number 8, okay, we start fresh lah. Okay, so we can continue question number 8. Sambung dengan section B. Okay, it will be interesting. Alright, so I think tonight we stop until here lah. Okay, we already live for 2 hours, hampir 2 jam. Right, thank you so much for all 91 student. Okay, thank you so much for following this lesson. Okay, cikgu pun tak sangka. Alright, I'm so happy. Alright, so see you again. Okay, subscribe to this channel so that you get the notification. And then also share with your friend lah from other schools so that more can join, more can get more knowledge. Okay, so the more the merrier kan. So everybody can berjaya kan, sama-sama berjaya. It will be great, right? So yeah, cikgu doa lah. So what we have learned tonight, you really understand. You can apply it. You can also share with your friend. You can explain to your friend. Okay. Yeah. So hopefully, if the question come out in your exam, you can answer. If you face problem about this in your daily life, also you can solve. Alright. Okay. So good night. Assalamualaikum. Okay. Sweet dream. Okay. Bye bye.